potential minus dV by dr, very technically minus I cap del V by del X plus J cap del V by del Y plus K cap del V by del Z delta V minus integral E dot dr. Reverse of this. Have we done this? Relation between field and potential. Then we dealt with a ring at a distance of x of radius a. Field will be gmx upon a square plus x square to the power 3 by 2. Potential will be gm upon under root a square plus x square. Then we dealt for a hollow sphere. At an external point, whole of the mass of the sphere will appear to be concentrated at the center.
Minus J.
Perfect. Field, I will never carry the negative sign. It's a vector. It tells me field is inverse. Right? For a hollow sphere, the result is very important for a hollow sphere. It will be called the shell theorem. For an external point, whole of the mass appears to be concentrated at the center. Minus Gm by R, field is Gm by R square. On the surface, potential minus Gm by capital R, field is Gm by R square. Inside, potential will be minus Gm by capital R. Whatever is the potential on the surface, everywhere inside potential will be the same, and hence the field will become. Everybody clear till here? 200% you should be clear. If I wake you people in sleep and ask you should give me the answer. Yeah.
Sir, on the surface the potential is constant, so the field should be 0.
Now listen, this doubt quite a few people will get. Do you see this? Field along x-axis, I will differentiate only along x-axis. Field is a vector quantity. Now, along the surface, field is 0. I don't mind. Whatever you are telling me is right. Field is 0 along the surface. Why? Because if I take two small elements on the surface here and here, delta V will be 0. So field along the tangential direction is 0. This field which I am telling you is not along the surface. It is perpendicular to the surface. When I am going from inside to outside, there is a change in the field, change in the potential. Right? Hence, along the radial direction, I will have a field. Is that clear? This is for a ring. X, E, field. Today's class will be very important from SHM point of view, because actually chapter SHM is not yet over. After today's class I have to teach a very peculiar concept of SHM in gravitation. Right? Even in the chapter SHM in HCV you have left 3-4 questions in between, if you people remember. Yes. Today we will be covering those. Hence then I can tell you the chapter SHM is almost over. That is the reason why these two chapters will be intermingled. We will first solve some part of gravitation, come back to SHM, then finish it off. Now, when you are dealing with a solid sphere, this is of mass capital M. At an external point, small r, greater than capital R, I want the potential and field. Now, consider a thin spherical shell this way. Consider a thin spherical shell this way. The mass of the spherical shell is dm. What will be the potential here due to the spherical shell? Minus g dm by small r. For any shell, for an external point, whole of the mass appears to be concentrated at center. For any shell, for an external point, whole of the mass appears to be concentrated at the center. Integration of scalars is a child's play for us. Scalar quantity, we never have an issue. Minus g. Above all, integral dm makes my job very easy. How the hell did you bring r out of the integral? It's constant. For every shell, distance from the center here is r. So it will be minus gm by r. And hence field will be gm by r square. That means either for a hollow sphere or for a solid sphere, for any external point, whole of the mass appears to be concentrated at the center. Either for a hollow sphere or for a solid sphere, for any external point, whole of the mass appears to be concentrated at. Will you remember the result?
Yes, sir.
On the surface, I'll replace small r with capital R because from external you are coming to on the surface. Potential is minus gm by r. Field is gm by r square. Inside I have a problem. I will solve. I need the right hand side part of the board. Take it down.
Sir, for hollow sphere, the inside part will be 0, no?
Obviously. For hollow sphere, inside part will be 0 means what will be 0?
E will be 0.
Field will be 0. Field. Don't tell me E. Field. Right? Now listen. For a solid sphere, inside the solid sphere, please do maintain silence, students sitting here. Even if you murmur, it gets amplified for them. Now I want to find out the field at a distance of small r here. I'll call this m1, I'll call this m2. Inside a solid sphere, at a distance of small r for you is standardized. It is the distance at which you want to find out the field or potential. Now in this case small r is less than capital R, in this case small r is greater than capital R. Right, here small r is less than capital R. Now field will be because of m1 plus field because of m2. Field at a distance of small r will be field because of m1 and field because of m2. Agreed?
Yes, sir.
Field because of m2 will be 0.
Yes, sir.
How did you say that?
So because every external point will have...
Every thin shell in M2 that I consider will give me a 0 inside. I will add all the zeros from small r to capital R, it turns out to be a 0. Is it clear to all? Now field because of M1 I will have to calculate G M1 by small r. G mass per unit volume 4 by 3 pi r cube into 4 by 3 pi small r cube upon r. M1 is mass per unit volume into volume. This r I kept as it is. Sorry, this is r square. Gm r upon r cube. That means till you come to the surface, the field is directly proportional to r. Distance from center. Once you come to the surface, the field will become inversely proportional to r square. Directly proportional to r, inversely proportional to r square. Till you come to the surface r. So inside the solid sphere, as I am moving away from the center, this will be the formula. Quite a few times we would prefer to write this formula in terms of density. Today's class itself you will see that. G, because this mass is the total mass of the sphere. M is equal to M1 plus M2.
Yes, sir.
So students have a confusion with the mass quite a few times. Hence to avoid that, G into density into 4 by 3 pi capital R cube upon R cube into small r. This will be 4 by 3 pi dgr. Clearly you can see field is directly proportional to, density will remain constant all through. Capital G is a constant, others are constant, so field is directly proportional to the distance. So it is directly proportional to r, it's a straight line. Once it comes out, it is inversely proportional to r square. Clear? Result is important. We will exploit this to the maximum extent in today's class. Quick. Now listen. Suppose you are dealing with Earth. One important statistics that we give you is, this is R, this is small m, this is capital M. Capital M is the mass of Earth, small m is the mass of the body. What will be the force experienced by this? It will be m into capital E. M is
Mass of the body.
mass of the body. Capital M will be the mass of Earth. E will be because of Earth.
Yes, sir.
Because of Earth, on the surface of Earth, it will be gm by r square. Yes or no?
Yes, sir.
Now this will be m into a, mass into a. Now on the surface of Earth, acceleration has been given a special name called small g. Acceleration due to gravity, m gm by r square. So small g is gm by r square. We will use this extensively. It's a must that you remember this. Then you may ask, numerically, don't you think E is same as small g? Yes, field and acceleration due to gravity numerically will be the same. You have been telling us potential energy of a body is mgh in particle dynamics. 1 second, all of you pay attention here. Here this is Earth. Now if I ask you for potential energy, this will be potential into small m. Yes or no?
Yes, sir.
Potential energy is potential into small m. Potential energy will be defined between two bodies. So capital M, what is the potential it will give on the surface? Minus gm by r.
Sir, Kharghar. Sir, can you please wait, sir? It is not.
Kharghar, are they connecting from that side? कर क्या रहे यार ये लोग यार खारघर का क्या कर रहे हो नहीं दिख रहा है बच्चे बोल रहे हैं वेट करने के लिए बात कर लो खारघर if you people are okay raise your thumbs
Sir, image is not clear.
image is not clear वही तो उनको दिखाना चाहिए हमें this should be clear 1 second all of you wait take it down till here we'll wait for Kharghar set करो Kharghar का जल्दी करो
On high towers, it's a random field comes. The wires supposed to come out
ग्रेविटी के साथ इलेक्ट्रिक फील्ड के बारे में डिटेल लाइटनिंग पढ़ाऊंगा राइट ग्रेविटी में लाइटनिंग कहाँ समझा
field or acceleration is not identical.
numerically they are the same yes
So, what will be the potential inside a solid sphere?
relax 10 more minutes for that to come हर चीज का एक मुहूर्त होता है
So acceleration due to gravity is a characteristic of the field.
ना sophisticated English नहीं use करने का numerically they are equal they mean काहे को confuse करते हैं very simple
सर वो एप्लीकेबल एम जो है वो एम मास ऑफ अर्थ है ना
obviously this is mass of the body small m capital M is mass of earth
ओके
force experienced by small m will be m into E
हाँ
because field is force per unit mass because of earth I found out the field on the surface Kharghar connect किया disconnect किया क्या हुआ
Sir, we are there. You can proceed, sir.
okay thank God now listen this point is important small m is on the surface of earth I want to know the force experienced by small m because of capital M so because of capital M the field is this that into small m I will get the force technically I should equate it to m into A acceleration due to gravity is given a special symbol called small g right hence small g is gm by r square now potential energy of small m on the surface of earth potential here is minus gm by capital R due to earth that into small m but you have been ditching us in particle dynamics you told us mgh and on the surface of the earth you told us 0 now you are telling me it will not be 0
So potential energy is based on reference.
Now listen, if this is at a height of h, if I call this to be u initial and u final, here it will be v into small m, potential energy. Agreed? What will be the potential due to earth on the surface? Minus gm by r plus h. At this particular point, small r is r plus h. That into small m. What will be delta u? U final minus u initial. U final minus g capital M small m by r plus h. Minus of minus g capital M small m by r. Minus gm small m r into r plus h. R minus r plus h. Hope my simplification is correct. I took negative sign outside. That means this will be positive, this will remain negative. So this will be r minus r plus h. Am I right?
Right.
No.
Yes sir, मतलब वो माइनस इधर आएगा प्लस इधर आएगा तो मतलब r तो सेम ही है ना माइनस.
Fine. Gm
Sir. Minus h. H minus.
minus h. Is that right? Now Gm I will substitute from here, small g into r square. Small g into r square. Right? This is m. H. R into r plus h. This is delta u according to you. Right? Now we tell you, in particle dynamics you have always taken height to be 1 meter, 2 meter, 3 meter, 10 meters, 100 meters. Radius of earth is 6,400 kilometers. So h is very small when compared to r. It will add only in the second or third decimal. So h can be neglected when compared to r. So denominator I have r square, numerator r square. I am left with equivalent to mgh if h is much smaller than r. Hence in particle dynamics we were telling you potential energy was mgh, yet we were bluffing. Potential energy absolute is not defined. Potential energy difference. If I told you my potential energy here is mgh, I am telling you the potential energy difference between these two, assuming this to be 0. That's why I told you mgh from earth. Then I told you take 0 on the surface of the table. Your wish. I can take anywhere because technically I am telling you potential energy difference between the 2 points. Are you clear with that? And it will be mgh if and only if h is much smaller than r. If h is 10 kilometers, 20 kilometers, do not take mgh. Please go by the difference of potential energies. This will be u initial and this will be u final. Clear with that? Quick. You want me to wait? Put it.
Sir, what maximum value can be considered?
10-15 meters, not more than that.
64,000 kilometers. Can take 1,000.
6400.
100 kilometers. Radius of earth.
Sir, till how far the field of earth is active?
Infinity.
Sir, is gravity zero at the center of the earth?
Yes.
We'll come to that. Oh, you are asking gravity. Field. Gravity means do you mean field?
So acceleration due to gravity.
Wonderful. It will be 0 at the center of earth.
Sir,
Huh?
sir, for that radius will turn to infinity.
Why the radius will turn to infinity? G capital M small r by r cube. Small r is 0. Field is 0 at the center of the earth.
Sir, please move.
Huh?
Can we call U initial to be the absolute potential?
Come again?
So can we say U initial to be the absolute potential?
Absolute potential is never defined. Always potential difference is defined. So there is nothing called absolute potential. If you are telling me the potential at this point, You are telling me the work done in moving a unit mass from infinity to this point. So absolute potential is never defined. It is always potential difference. What did you tell me here in SHM? You dig a tunnel from the north pole to south pole of earth and drop a body. Right? When you drop a body, tunnel from north pole to south pole of earth and drop a body. We said the time period will be 84.6 minutes. Now when I drop a body here, as it comes here, let me assume this distance to be x. What will be the force experienced by that mass? M into E. The mass of small m is dropped in the tunnel. Force experienced will be M into E. Please do maintain silence. Quiet. 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 Listen to me. Now this will be M into, what will be the field here? G capital M by R cube into small r. Small r is x in this particular case at a distance of x from the center. Right? Now this will be M into A, mass into acceleration, M into Gm by R cube into x. A is equal to gr square by r cube into x. Where did you get this? Small g is gm by r square. We derived 5 minutes back. So gm I put as small g into r square. A is equal to g by r into x with a negative sign because a and x are not in the same direction. So what will this be? Omega will be under root g by r. Time period will be 2 pi under root r by. Time period will be 2 pi under root r by 84.6 minutes. What if the tunnel did not pass through the center? I drop a body here. As it is moving to the other end, the body will come somewhere here. I will take this distance to be x, while this distance to be, don't worry about it. Take it as theta here. Now for me, E will be in this direction. Be clear about it. Restoring force will not be ME. It will be ME sin theta. ME sin theta. Why? Restoring force is the force which is pulling it to the equilibrium position. So if this is ME, in this direction ME sin theta. Is everybody clear about it? Now this will be M into A. This will be M into, what is the value of the field? G capital M by R cube into this distance. What will this distance be? X by sin theta into this sin theta. Small m, E will be this quantity and then sin theta. G capital M small r. Small r was the distance of this point from the center. The distance is x by sin theta. Now these both will get cancelled out. These both will get cancelled out. Gr square by r cube into x. A is equal to minus of g by r into x. Time period will be 2 pi under root r by 84.6 minutes. Strange, right? Hence God is great. He did all these calculations before creating earth. Why we don't know. Yet we don't know why. Why should it be 84.6 minutes? No idea. But it is 84.6 minutes. Fine. Quick. Now, HCV gave one wonderful problem in SHM. Look at the beauty in it. He didn't give you this in gravitation. That means he doesn't want you to solve using the concepts of gravitation. He wants you to solve using the concept of SHM. But actually he didn't give an SHM. If you are projecting this body with a velocity of under root gr, he is asking you the time it takes for it to come till the other side of the earth. I have a serious problem with that. What is it? The moment you give velocity, it will come out from the other side. Conservation of energy. Once it comes out, field is directly proportional to 1 by r square. So force is directly proportional to 1 by r square. Kahe ka SHM, it is not an SHM anymore. So we have a serious problem. But he gave you this question in SHM. Problem is not in SHM. But he gave you the question in SHM. That means HCV wants you to convert this problem into a simple harmonic motion. How do I convert this into a simple harmonic motion? I will assume a hypothetical planet of radius x such that when the body is dropped from here, it will come here with a velocity of under root gr. I will assume a planet, hypothetical planet of the same density. I will have to keep something constant. Same density such that I am not projecting it here, I am dropping it from here. When it comes here, it will have this velocity. So I have not changed the problem. I have not changed the problem. How I gave the velocity I have changed. I didn't push it. Instead I dropped it from a height at a radius of x.
3r by 2.
How do we know that?
Root 2 g velocity होगा.
कुछ भी
अरे yes.
काइनेमेटिक्स का फॉर्मूला यूज कर रहे हो. काइनेमेटिक्स only uniform acceleration. Right? Now there are two important intricate concepts here. If I would have dropped the body here, omega would be under root g by r. You calculated that. When you drop the body from this surface, omega will be under root g dash by x. G dash is the acceleration due to gravity on the surface of the hypothetical planet. X is the radius of the planet. Without actually solving, I can make a guess both of them are the same. How are you telling me that? In SHM, time period is independent of amplitude. In SHM, I never asked you the time period, giving you different amplitudes. I displaced it by a distance of x. Was there a restriction on the value of x? No. Only thing, this should be within elastic limit. I pull it by 1 centimeter and release it. I pull it by 1.1 centimeter and release it. Or I pull it by 0.9 centimeters and release it. Time period was the same. Amplitude in this case when I drop it from here was capital R. In this case amplitude will be x. Time period is independent of it. I have proved that these both are equal using the concept of SHM. Now I will prove that these both are equal using the concept of gravitation. Pay attention here. What did you tell me G was? 4 by 3 pi dg smaller. Yes or no? I have taken this hypothetical planet of the same density. Now what will G dash be? G will be here capital R. G dash will be 4 by 3 pi dgx. G by R, will it be equal to G dash by x? G by R is equal to G dash by x. So, if any one of you is planning to build an earth with the same density and then dig a tunnel from North Pole to South Pole, again it will be 84.6 minutes. So, it is a mystery. If ever I have the ability to create a universe of my own, competing with God, will I have a choice of creating a universe with a different model? Probably no. This is the only unique model in which you can create the universe. Strange, right? It's actually true. Irony is that no two people in this universe are alike. Even if they are identical twins, there will be some differences. Because Pauli's exclusion principle says in chemistry, no two particles will have the same set of 4
Quantum numbers.
so there are no two particles alike. Every person is unique. Every person is unique. This is also called as predeterministic universe. You will be surprised to listen. If you were to be born in this form, it must be to the same set of parents. Biological engineering, the gene mutation says, you will never come into existence exactly in this form, with this nose, with this eyes, with this hair, with this face cut, with this temperament, with this mindset, with this color of the skin. You will come into the world only to the same set of parents. You have no choice. That means, if you go up the geometric progression, nobody had a choice up the lane from our ancestors. You were determined to be born. How do you say that? Because The light which is coming from the farthest star for you has started from there few million years back. Light year is the distance traveled by light in 1 year. What you see as today's night sky has been decided millions of years back. Tomorrow's night sky is also decided. Only thing you will see it only tomorrow. Tomorrow's night sky was decided million years back. Day after tomorrow's night sky is also decided few million years back. Today the star there exists or not also I don't know. But today you receive the light. Today you will see the star. At this instant the star may not exist there. Right? So future is completely decided. Just chill. Right? Suppose you stop working and you say future is decided here, either way I'll get into IT or not is decided. Then it was already decided that you will not work. Right? So this is called predeterministic universe. You hear to the other side of the coin of uncertainty universe, you will feel that is also 100% right. There are two different schools of physics. It's strange but true. Right? Hence, have a look at this. Eliminating this, how do we solve this problem? Now my requirement is, you have converted the problem into an SHM by dropping a body from here of a hypothetical planet with the same density as that of Earth and radius h. By the time it comes here, the velocity will be under root gr. How do you make sure that? I will find out the velocity here as under root gr and then find out x. How are you going to do that? V is equal to omega root over of a square minus y square. Velocity expression in SHM. This velocity here should be under root gr. Square it. Omega, either you take g by r or g dash by x. It will be the same. Under root g by r. Square it. Amplitude is x square. What is y? R square. That means this should be the velocity when the distance of the particle from the center is r. Gr is equal to g by r into x square minus r square.
Root 2r.
X is equal to r root 2. This should be the radius of your hypothetical planet. For this particle to acquire this velocity when dropped from here. X is equal to r root 2 should be the radius of the hypothetical planet. When this particle, when comes to a distance of r from the center, acquires this velocity. Your question has come down to find the time taken by the particle to come from here till here. Convert this into a phasor. I hope this is a straight line. If it is not a straight line, assume that it is a straight line. The phasor particle. When we started SHM, we said, what is SHM? If a particle starts from here and goes about in a circular path, the foot of the perpendicular is your SHM. Yes or no?
Yes.
Now, here the foot of the perpendicular is going down. That means the phasor should be here or here? To the left. So the phasor particle is here. This is r root 2. What will this angle be?
45.
Wonderful. The foot of the perpendicular is going down. Now you are asking me time taken by the foot of the perpendicular to come from here till here. That means if the foot of the perpendicular here is going down, phasor will be to the right or left? Left.
Left 90 degrees.
So once again, this is r root 2 and this is r. This angle is 45 degree. You are asking me the time for the foot of the perpendicular to come from here till here. You are asking me the time for the foot of the perpendicular to come from here till here. It should be equal to the time for the phasor to come from here till here with the same angular velocity. Time will be theta by omega. Theta is pi by 2. Omega is under root g by r. This will be pi by 2 under root r by g. He taught you the concept of converting a non-SHM into a forcible SHM. He taught you the concept of phasor, and he taught you how to find out the time taken for a particle to cover one part of the SHM. Time taken from here till here is capital T. One part of the SHM, this is the way you will find out the time. The problem is very important. You should understand every bit of it.
So there are two schools of thought.
If you people understand this, potential due to a solid sphere, I kept it in abeyance. Solid sphere, understand this value of potential. I need the potential at a distance of small m. This is m1 and m2. m1 and m2. I want the potential at a distance of small r as potential due to m1 plus potential due to m2. Potential due to m1 and potential due to m2. Potential due to m1 on the surface of m1 minus g m1 by small r. Now potential due to m2. This I will simplify first. Minus g mass per unit volume 4 by 3 pi r cube into 4 by 3 pi small r cube by r. Mass per unit volume into volume. This will go minus gm r square by r cube. Now I have to deal with this. Potential due to m2, it will not be 0. I will consider a thin spherical shell at a distance of x of thickness dx. Potential due to this shell dvm2 will be minus g dm by x. This will be the potential on the surface of the shell.
Sir.
I am calculating, you will see that. Now listen, m2, I will take one thin shell in m2. Because of the shell, whatever is the potential on the surface, everywhere inside it will be the same. For a shell, whatever is the potential on the surface, everywhere inside it will be the same. Now a thin shell considered, what will be the potential on the surface? It will be this. Minus g mass per unit volume 4 by 3 pi r cube into volume of the shell 4 pi x square dx upon x. This will be the potential due to a thin spherical shell taken in m2. This will be the potential on the surface. Inside it will be the same. Integrate this potential. Minus gm 4 pi will go. 3 will come to the numerator. R cube integral x dx. Least value of x is small r. Maximum value of x is capital R. You are going from small r to capital R. Vm2 will be minus 3 gm by r cube. This will be x square by 2. R square minus r square by 2. Right? This will turn out to be minus 3 gm by r cube 2r cube r square plus 3 gm r square small r square by 2r cube. Right? Or instead of writing that, just bring 2 outside. That will do. Just bring this 2 outside. Now add this. This will be Vm1. Potential will be minus gm r square by r cube minus 3 gm by 2r cube into r square minus r square minus gm by 2r cube 3r square minus r square minus gm by 2r cube 3r square minus r square. This is the expression for potential inside the solid sphere. Ironically, students remember the expressions outside the sphere, but they forget the expression inside the sphere. JEE people hit exactly at this point. They gave a question on this which I will show to you for 2 marks. For 2 marks they asked a question on it. If you remember the formula, it is actually worth 2 marks only. If you don't remember the formula, conservation of energy you will have to derive this. For 2 marks you cannot do it. So they were in soup. People who did not remember this formula left it. Hence, make sure that you remember this formula. In gravitation as well as electrostatics, these formulae will be a replica of each other. Take it down till here. Tell me the field because of an infinite long wire.
G lambda by R.
Who told that here? Akola, others will maintain silence. Pin drop silence. The boy standing will have to speak. If you do not know the answer, kindly pass it to your neighbor. Stop murmuring. Stop murmuring. He's wrong. Next. Nerul, first bench. Center boy. Stand up and slap yourself once. I want to see that. Stand up. Stand up. I should feel the pain. Stand up. Slap yourself once. Wonderful. Sit down. Don't open your notes again. Beto. Akola, why did you sit? Stand up. Let your next boy stand up and then you sit. Hey, Nerul, beto na yaar. Nerul, boy, sit down. Infinite long wire field. Next. Please speak. Akola, others will not talk. Maintain silence, sir. Only the student who is standing will speak.
Sir, 2G lambda by
2G lambda by R. Right. Sit down. Switch off the mic, Akola. Kalyan, switch on the mic. Semi-infinite wire. Kalyan, the person who moved to the fifth bench right now, white and red shirt boy, who is hiding himself. Stand up. 1, 2, 3, 4, 5. Stand up, stand up. Yeah. EX value.
G lambda by
G lambda by R.
EX both G lambda by.
Now, what do you want me to put for EY? Same person. Kalyan.
Sir, same sir.
What does same mean?
G lambda by.
What does lambda stand for?
Sir, mass per density for the wire.
Mass per density?
Linear mass density, sir.
Linear mass density. Mass per unit length. Perfect. Sit down.
Mass per unit area.
Thane, switch on the mic. Kalyan, switch off the mic. Thane, last bench boy. Thane, last bench boy. Blue shirt. Field at the center of a semicircular ring.
Zero.
No, it is not zero यार. सुनने में भी दिक्कत हो रहा है यार. The person हाँ. Person who is prompting it for him, kindly help him out properly. Don't ditch him.
बोला ना. Sir, 2G lamp.
बंद क्यों कर रहे हो यार माइक बीच में? 2G बंद कर दोगे?
Sir, 2G lambda by.
2G lambda by R.
Lambda by.
You You are saying 0 in the start. Whoever gave you that answer, hit him one on the head. Whoever told you 0 in your batch, hit him one on the head. Right. Now switch off. Pune, switch on the mic. Pune, switch on the mic. To my left, last bench. To my left, last bench. To your right, last bench. Pune students will have to maintain silence. Pune students will have to maintain silence.
M by A square x square under root A square x.
What does A stand for? Acceleration of small m or capital M?
Not acceleration, so distance.
A stands for distance.
Radius.
Who asked you people to prompt that answer? Who all prompted answer as radius? Raise your hands once. And what does X stand for?
So length of that particle from the ring, center of the ring.
Okay, distance of that point from the center of the ring. Distance of this point from the center of the ring. Clear? Sit down. Switch off the mic. DADAR, switch on the mic. To my left, second row, the first girl. To your right, second row, first girl. To my left implies second row. To my left. To your right. Tell me the expression for field.
Negative gm upon a square plus x square the whole raised to 3 by 2. Gmx.
Gmx. A square plus x square to the power 3 by 2. Do not carry negative sign. Tell me the field is inverse. Clear?
Okay.
Switch off the mic. POWAI, switch on the mic. The most important thing in gravitation which you should remember. If I push you off from a top floor of a building and you are falling down, I ask you then what is the field? Tell me if the field properly then, even in such a shocked state. Is it clear? Say yes. Louder. Beto. Nerul. Solid sphere. Smaller. Potential. Nerul. Last bench to my right, just in front of the pillar. Last bench to my right, that means to your left. To your left, last bench. Yeah, tell me the potential at an external point for a solid sphere.
So minus gm upon r square.
R square.
So sir, r minus gm upon r.
Am I right?
No sir. Sir,
Why?
small r.
Wonderful. Tell me the expression for field, same person. Wait, not same person, the person sitting in front. Up, beto. Person in the front, hit him one on the head and wake him up. Field.
Gm by r square.
Small r, capital R.
Capital. Small.
Direction of the field here, outwards or inwards, same person.
Inverse.
inwards. Field will always be attraction. Sit down. The person sitting in front, expression for potential on the surface.
G minus Gm by R,
Small r, capital R.
capital R.
Wonderful. The person sitting next to you, besides you, field.
Sir, minus Gm by R. Zero, sir.
यार potential दिख रहा है ना यार. On the surface, I will replace small r with capital R. You are giving me shock treatment. Minus का है का field के लिए minus I will never carry. So many times we have written on the board. Gm by r square. बैठो. आने का चांस हो गया ना यार. अंधेरी. हाँ. ये कौन सा सेक्शन है? नहीं ऊपर राइट. 5 batch 5. Switch on the mic. Listen. ये सामने वाला रूम है. The boy behind the green t-shirt boy. Green t-shirt के पीछे जो boy बैठा हुआ है. हाँ. Stand up.
अपन को बोलो अपन को बोलो
हाँ. अरे ग्रीन टी शर्ट बॉय के पीछे यार. आप ही खड़े रहो. गलत नाम बोल रहे हो यार तुम. Right? Listen. Today only we derived the expression for field inside a solid sphere. If you do not know, kindly see the book and tell me the answer. See the book and tell me the answer. I'm okay. Today only we derived field inside the solid sphere. Louder. कहाँ पर ढूंढने में भी दिक्कत हो रहा है यार. क्या कंसंट्रेट करते हो यार आप लोग क्लास में. Quiet. Louder. Gm small r by r cube. Green t-shirt boy, can you tell me the expression for potential? नोट्स देख के बताओ ना यार. अभी डिराइव किया है हम लोगों ने. कुछ भी बोल देते हो. Right, minus Gm by 2r cube into 3r square minus r square. Everyone sitting in the class, please understand, I am doing this intentionally to make sure that you understand the importance of remembering this formula. If you can afford to forget it, you are paying a very heavy price for it. Next class, I will again invest 15-20 minutes this way. Each section say, I'll make one student stand and ask for a formula. I need the answer spontaneously. Am I very clear about it? You will use this so many number of times. I will show you how JEE people played with this formula. Unless you remember the formula, you cannot solve those questions. And they'll ask you this for 2 marks. You cannot afford to derive it. You know how to solve it. All that you will have to do is conserve energy. 2 marks are very costly for me. I don't know how you value it. 2 marks will turn tables upside down for us. Every formula on the board you should know it by heart. Is it very clear to all? This is a ring of mass capital M. This is a solid sphere of mass capital M. Both of them are of the same mass. This is R, this is R. Distance between their centers is R root 2. distance between their centers is r root 2. Roorkee people asked you to find the force due to the sphere on the ring. Find force due to sphere on ring. Now there is a smart move that you should implement here. They asked you force on the ring due to the sphere. Very technically, due to the sphere, if I consider on the ring, the field will be this way. This will have a horizontal and vertical component. All horizontal components cancel out, all vertical components will add up. I will have to integrate. Due to the sphere, on a small element of the ring, I will get df. df sin theta must be integrated. Right? You will get the answer if you do it the right way. But there is a much shorter way to look at it. Newton's third law should come to our rescue. Every action has an equal and opposite reaction. You are asking me force due to sphere on the ring. I will calculate force due to ring on the sphere. Force due to the ring on the sphere. This is r root 2. This value is r. What will be the field here? G, M, x is r root 2 upon a square is r square plus r root 2 whole square whole to the power 3 by 2. This is the field due to the ring at this particular point. For any external point as far as the sphere is concerned, whole of the mass appears to be concentrated at center. Now whole of the mass of the sphere I can consider to be a point object. Force is m into E. This is G m square r root 2 upon r square plus 2r square to the power 3 by 2. Is the logic clear? All of you, quick. What you have calculated is force due to ring on sphere. Force due to ring on sphere. Every action has an equal and opposite. Action and reaction will never be on the same body. Action is force due to ring on the sphere. Reaction is force due to sphere on the ring. Ring is of mass capital M. This is semi-infinite wire. Mass per unit length of the semi-infinite wire is going from the center till infinity. Find force due to ring. We have done this?
Yes, sir.
Good. Save some time. Now when we deal with Earth, understand one logic. On the surface of Earth, you are telling me G is Gm by R square. You have derived this in today's class.
Yes, sir.
At a height of h, G dash is Gm by R plus h whole square. G dash is Gm by R plus h whole square. So G dash by G, R by R plus h whole square. You can also write this as 1 plus h by r whole to the power minus 2. Right? G dash is G into 1 minus 2h by r. How did you get this? Opening up using binomial theorem, neglecting the higher powers. This is applicable if and only if h is much smaller than r. Remember this approximation in your CET. This question is very famous. Intentionally they will give you r by 2 or r by 4 for h. For instance, if you take r by 2, you get g dash to be 0, which is wrong. Right? I cannot use this formula if h is r by 2. I should use this particular formula. Suppose I go to a depth of h. That means this distance will be r minus h. Now I will convert this formula of G in terms of density because it is comfortable for you. As I am going inside, I assume the density of earth is constant. Right? So G will be, instead of this formula, 4 by 3 pi dg small r. Right? All that we have done is replaced mass with density into volume. Now on the surface, this is capital R. G dash is inside. 4 by 3 pi dg capital R minus h. Small r is the distance from the center of earth. G dash by G will be R minus h by R. G dash is G into 1 minus h by R without any approximations.
Yes, sir.
Somebody was asking me, is G 0 at the center? Put h equal to 0. There is no approximation in it. This is universally valid all throughout the earth, inside the earth. Hence, if I put h is 0 at the center, G dash will become 0. Variation of acceleration due to gravity from the surface of earth above and below. That means you are trying to tell me, even when I go up, it will decrease. Even when I go down, it will decrease. Hence it is safe on the surface of earth. G is maximum on surface of earth. Quick.
When we put the h equal to r,
Sorry, yeah. H equal to R. At the center of the earth, at center of earth, H is equal to R because H I am taken from the surface. G dash will become 0. On the surface of earth, H will be 0. If H is 0, G dash is G. Orbital velocity. What do you mean by orbital velocity? There is a particle which has been given a velocity of v0 when it is at a height of h. Particle given a velocity of v0 at a height of h. G capital M small m by r plus h whole square provides the required centripetal force mv0 square by r plus h. G capital M small m by r plus h whole square provides the required centripetal force. V0 under root gm by r plus h. Close to the earth's surface. Close to the earth's surface. H is much smaller than r.
Yes, sir.
Orbital velocity will be under root gm by r. Close to the earth's surface, orbital velocity will be under root gm by r. Right? Orbital velocity is the velocity with which a satellite should be placed into the orbit so that it does not need any fuel anymore. It is going round in a circular orbit. Who provides the required force for it to move? Centripetal force, force of attraction between capital M and small m. What is the fuel used in a satellite? Nothing. Gravity. What is the fuel used by moon? Gravity. Then why do we use solar panels? To run the electronic gadgets on the satellites. What will be a geostationary satellite? This can be a geostationary satellite provided its time period is 24 hours. Stationary, if we launch a satellite, it should be above us at rest. All communication satellites we need above us nowhere. So a geostationary satellite is very important. Time period will be 24 hours and it should be rotating in the direction of Earth. If it is rotating opposite to the direction of Earth, it will never be above me. Only 2 times it will be above me. Right? To add to that, it should be in the equatorial plane. Equatorial plane. Geostationary satellite implies the orbit should be in the equatorial plane. Can I have a satellite like this? Yes, you can have comfortably a satellite like this. Permitted? till when the plane of the satellite passes through the center of the earth, the force of attraction between earth and the satellite will provide the required centripetal force. Then what kind of a satellite I cannot have? I cannot have a satellite like this, not permitted, it will fly off tangentially. At the first place, why are you interested in such a satellite? Obviously we will be interested in because there will be a country, the northern hemisphere, European countries on the top, they will be going around in this orbit. For them, is satellite above will not fulfill the requirements, right? Because you cannot launch this way. So they will launch, if they are going about this way, they will launch one satellite here, one satellite in this orbit, one satellite here and one satellite here. So they keep switching. For your very good information, even India is not on the equator, it is above the equator. So we also need 2 satellites for 24 hours communication. If ever you people watch Doordarshan programs at night 9 o'clock, there will be an information on the television network. Hereafter the transmission is from INSAT 1B. Night 9 o'clock, for approximately 30 seconds the network will get disconnected and there will be a message on the TV. Hereafter the transmission is from INSAT 1B. So for first 12 hours, because India comes somewhere here, first 12 hours you will have a transmission from a satellite in this orbit. Next 12 hours you will have transmission from a satellite in this orbit. Right? As you are going closer to the northern hemisphere, you need more number of satellites for 24 hours communication. Right? You saw the movie Independence Day. In that, the hero of the movie, say there are 2 heroes. The hero runs into the presidential palace to explain something to the president. Immediately the president orders the evacuation of the presidential palace. The concept is like this: the foreign body can cover only this part of the globe. It has taken all the satellites into its control. He tells the president the first piece of information in so many minutes that will be above the presidential palace. So immediately the president orders the evacuation of the presidential palace. Second information, it has taken 2 satellites into its control, one Russian satellite and one US satellite, which are equipped with nuclear arsenal. Within so many hours, so many minutes, so many seconds, they will form an equilateral triangle equipped with nuclear arsenal. If they are fired simultaneously, whole of the globe will be covered. Hence the theme of the movie was, before so many hours, so many minutes, so many seconds, they should destroy this foreign body. First attempt that they make, they fail. Second attempt that they make after installing a virus in it, so that they are able to destroy it. You didn't see the movie? See it. It is worth watching it once. Right? 3-4 years back, even Star TV network, when they used to give timing of a particular program, they used to give you UAE timing and Bangladesh time. Right? The reason being, if this was the Star satellite, UAE and Bangladesh were the areas covered. Hence they used to give UAE and Bangladesh. Nowadays you get the network even on the other side of the globe, Star network even in America, because they are taking the slot from a neighboring satellite. This satellite directly cannot telecast to whole of the globe. Clear? Quick?
So the India को 2 क्यों चाहिए? Center से तो पास कर ही रहा है ना अपना.
India comes somewhere here, right? So I need one satellite like this. When India is going around this way, I need another satellite. When this comes here, I need another satellite on the other side.
तो वो बीच का part. अरे वो satellite.
Yeah, from here till here, this satellite will cover. It's not only one point, right? It will cover a cone-shaped structure.
Yeah.
This complete structure. Quick. Passing through the equator. Plane passing through the equator. I can have a geostationary satellite only if the plane is passing through the equator. It should have a rocket propulsion system to change its orbit anytime. You saw the movie Gravity?
Yes.
In space you want to shift the orbit, you need a propeller. For her to move also she uses a gas extinguisher. That gives her momentum in the backward direction. But again, to come to rest, it is so painful. She collides with the spacecraft and comes to rest. Something is set into rotation, you cannot stop it. They show one particular long cable going round the spacecraft. She cannot control it.
So can't they use gyroscope like for what you told for moving? So like changing, like something they've changed the director.
Why do you want to use gyroscope there for what?
Sir, but they use in small space probes for changing the direction.
Fine, no issue. There is nothing but two discs in the opposite direction. One rotates in clockwise, one rotates in anti-clockwise.
So why can't they use it for the big satellite like gyroscope?
How do they know what kind of accident they will make? You are speaking about the movie Gravity, right?
Sorry?
You are speaking about the movie Gravity, right?
Not any. अभी तक नहीं.
Now listen. Two reasoning questions asked by HCV. If a nut or a bolt is released from a satellite, what will happen to it? It will also become a satellite.
Yes.
A nut or a bolt is released from a satellite. What will happen to it? It will also become a satellite. How do you send a nut or a bolt to ground? If this is Earth, this is a satellite. From here you want to send something to Earth. Now if the satellite is going with an orbital velocity under root gm by r plus h, please throw the body in the opposite direction with the same velocity as v0 with respect to the satellite. So that velocity of small m with respect to the satellite plus velocity of satellite with respect to the ground should turn out to be 0. So it will fall vertically. If from inside the satellite you can open a window and you want to throw something to Earth, throw it in the opposite direction with the same velocity as that of the satellite. So that velocity of the body with respect to the satellite plus velocity of the satellite with respect to ground will be velocity of the body with respect to ground, which will become 0 and it will fall onto the ground. Fine?
Yes, sir.
All of you? Now,
Fall exactly in the
it will fall straight.
So even if it is not, the magnitude is not same in the opposite direction, it can fall down after.
It can fall down, may not fall straight. With slide. I will leave you people with a particular problem as homework. सुन लो, ध्यान से सुनो question. This is Earth. This is Sun. You are standing here at mid-noon. Mid-noon, what will be the time?
12.
Wonderful. Sun is pulling you in this direction. Earth is pulling you in this direction. There will be normal force between you and Earth. So the equation is Fs plus N is Fe. N is equal to force due to Earth minus force due to Sun. Midnight. Normal force. Force due to Earth. Force due to Sun. N is equal to force due to Earth plus force due to Sun. University physics, and as picked up by HCV, they are asking you a question. Their question is your Earth, you were taught in Newton's laws that normal force is your weight, yes or no? Say something. Yes, sir. Hence, according to what we have learnt in gravitation, your weight at midnight should be greater than your weight at mid-noon, provided you have the same meal as lunch and dinner. Will that happen?
No.
Why does this give you the wrong answer?
It's the home.
First homework, reasoning question from HCV, this is. Another reasoning question from HCV. Why I am asking you both the questions simultaneously is they both are slightly in tune. Here some students may feel force due to sun is negligibly small. It is not. It is 1000 times more than the force due to earth on you. Force due to sun on you is 1000 times more than force due to earth on you. Are you clear? Same question they asked in one more way. Force due to sun on moon is 1000 times greater than force due to earth on moon. Green t-shirt boy of Andheri. Green t-shirt boy of Andheri. Please listen to the second question. Right? Will you? Wonderful. Force due to sun on moon is 1000 times greater than the force due to earth on moon. But yet, somehow, earth manages to make sure that moon goes round itself and not round the sun. Why? And how? What is the bribe that earth gives moon? How does it manages to make moon go round itself when the force on moon due to sun is 1000 times greater?
So the attraction force of moon towards
Sir?
the earth and force energy
The velocity, the orbital velocity is
Sir,
Speak.
sir, I have a reason for why. Sir, I have reason for why we are not experiencing the force, means we are not affected by the heavy force to the sun.
Please
Like it
speak.
now.
Please speak.
We are moving around the sun at a very high speed, so we are experiencing centripetal force from the sun, but we have not considered that. Means we are actually experiencing centripetal force from the sun for our circular motion around the sun, but since we are taking rest, means we are taking this, seeing this from the frame of earth, so there is pseudo force of the sun on us, of the frame. So that's why this is being balanced.
What's your name?
Shreyas.
He did an awesome job. I will not explain it because that will become a hint for you people. Right? Your answer is completely right. All it needs is detailed explanation for the others. Fine. The others will attempt and come to the next class. Fine. Second question you remember. Despite the fact that moon experiences a force 1000 times greater due to sun, yet it goes around the earth and not sun. Why?